Namaskar, welcome to the channel Anka Ananda Haran. After a long gap, we are again coming back to the concept of applied linear algebra. Today we will discuss chapter 4 of Gilbert Strang book. Again, the discussion is for just some of the significant aspects of the topic determinants for the examination point of view of the students. So, determinant is a concept which is well discussed in the intermediate level, that is plus two level. Today we will discuss some of its properties. If any matrix A has zero determinant, then it is said to be singular. If the determinant of the matrix is non-zero, then it is said to be non-singular, and non-singular matrices are invertible. And a matrix is invertible if and only if it is non-singular. A square matrix is invertible if and only if it is non-singular. And let us consider a parallelepiped having this structure where this point is our origin and this is my one point, this is another point, and this is another point. Then volume of the parallelepiped is the determinant of the matrix A11, A12 and A13, A21, A22, A23, A31, A32, A33. This determinant is nothing but the volume, and always we know volume of any structure is written in cube units. So if the volume of this parallelepiped is being asked, we are expected to find out this determinant, and the resultant, whatever positive or negative is coming, we are expected to write the positive value of the obtained value, and that is mod absolute value, and in cube units. Next is determinant is a plus or minus product of the pivots. That is, if there exists row interchange, then the determinant gets a negative sign. Hence, the whatever pivots we are getting, if we are multiplying them and their mod is same as the mod of the determinant. These are some of the aspects of determinant. Now the question is, let us discuss about some of the properties of determinant. Identity matrix is having determinant 1 because for a diagonal matrix, the product of the diagonal elements gives us the determinant. So here the diagonal elements are 1, 1. So 1, 1, 1 multiplied with each other gives us 1. Determinant changes sign when two rows are interchanged. Observe here, these two rows are interchanged, then there is a negative sign here. So determinant of every permutation matrix is plus or minus 1 because permutation matrix is obtained from identity matrix, and identity matrix are having determinant 1. So when there exists row interchange, that means they are obtained with plus or minus sign. Determinant depends linearly on the first row. Observe here, it is scalar multiple. So here in this case it is scalar multiple. The first row is multiplied with t, and t can be taken out, and here a dash plus b dash, it is abcd plus determinant of abcd plus a dash b dash cd determinant. Okay, so linearity property is satisfied. Similarly, if two rows of a matrix are equal, then the determinant is 0. Even if any row or column is a scalar multiple of sum of its rows or columns, then the matrix will be having 0 determinant. Here observe, subtracting a multiple of one row from another row leaves the determinant same. So what happened here? L times of second row is subtracted from the first row, but still the determinant remains same. Next, if a matrix is having 0 rows or columns, having 0 columns, then the determinant of the matrix will be 0. Similarly, if it is a triangular matrix, then product of the diagonal elements will be giving us the determinant of the triangular matrix. If A is singular, then determinant of A is 0, and if A is invertible, then determinant of A is non-zero. In that case, A inverse determinant will be 1 upon determinant of A. And product of determinant of A times product of determinant of B, that is determinant of A multiplied with determinant of B gives us determinant of AB. So here what happens? A and A transpose are having same determinant. Next question is permutation matrix. So here if A is invertible, then permutation of A, which can be written as LDU, where L is the lower triangular matrix, D is the diagonal matrix, U is an upper triangular matrix. So here this D, which gives us the product of the pivots. For any matrix having A1, these elements as its elements, what is the value of the matrix? Its determinant is observed. This is the value of the determinant. Also, this is one of the famous formula we have discussed several times in the classes. Observe here what happened. A and D are interchanging their places. B and C are just negated and 1 by determinant. Determinant is a combination of any row I times its cofactor. That means observe here ith row element and its cofactor plus second element of ith row and its cofactor. So any row you select, you take the element and its cofactor. Likewise, every element and its cofactor, their sum will give us the determinant. Also, cofactor is equal to minor into minus 1 to the power I plus j. Minor is the value of the determinant in which ith row jth element is being eliminated or taken out from the given matrix. Cramer's rule. Here what happens? We have the coefficient matrix, where in the coefficient matrix we have the determinant as, suppose here A is the Ax is equal to B. So A is the coefficient matrix, its determinant is being obtained. Let us write down its determinant given here is determinant of A. Now I have written the coefficient matrix in such a way that its jth column is replaced by this value. Okay, it is replaced by this value. So that is B. So then such a matrix obtained is called Bj. In the class I have discussed it as Aj, and the determinant is Dj. So Dj by determinant of A is D. It will give you the value of Xj. Determinant of Bj divided by determinant of the coefficient matrix gives us Xj. So this is all about Cramer's rule. Now suppose I have a triangle having coordinates x1, y1, x2, y2, x3, y3. Then its area of the triangle is half into this determinant. If the corresponding parallelogram is asked, then the area will be area will be this determinant itself without this half symbol. Twice the area of the triangle is the parallelogram. So here area of the triangle is being asked, so this question does not arise. This part I am not considering. Okay. So next question is, let us go to discuss about some of the aspects of determinant directly. Let A be a 4 by 4 matrix and determinant of A is equal to half. Then what about the determinants? We know that n by n matrix A with determinant D has K into A. Its determinant is how much? K to the power n into D. Now applying this formula, what about determinant of 2A? Determinant of 2A will be, determinant of 2A will be 2 to the power 4 into determinant of A, that is half, that is 8. Similarly, determinant of minus A is minus 1 to the power 4 into half, that is half. Similarly, determinant of A square is determinant of A whole square, that is 1 by 4. And determinant of A inverse will be how much? 1 upon determinant of A, that is equal to half. Okay. Next, similar type of question, another question. So here A is a 3 by 3 matrix, determinant of A is equal to minus 1. So what about half A? Determinant of half A is equal to half to the power 3 into determinant of A, that is minus 1. That is minus 1 by 8. Now what is determinant of minus A? It is minus 1 to the power 3 into minus 1. That is 1. What is determinant of A square? It is minus 1 whole square, that is 1. What is determinant of A inverse? It is 1 upon minus 1. Determinant of A inverse is equal to 1 by minus 1, that is minus 1. Okay. Next question is, find the determinants of a one rank matrix. Now observe, it is 3 row 1 column, it is 1 row 3 columns, so the resultant is a 3 cross 3 matrix with rank 1. Rank 1 means its determinant will be 3 cross 3 matrix determinant will be 0, because if the 3 cross 3 matrix is having non-zero determinant, the rank will be 3. But here the rank is 1. That implies always it will be of 0 determinant. In this way you can discuss. So the determinant is determinant of A equal to 0. In this way we can discuss. Or else after product, what will be the result? It will be 2 minus 1, 2. 4 times this row, that is 8 minus 4, 8. Again 4 minus 2, 4. Observe, they are scalar multiple of each other. If any row is a scalar multiple of each other, then the determinant is 0. That's why also we can write the determinant 0. Okay, from rank 1 without calculating directly we can get, and from this calculation also, this each row is a scalar multiple of 2 minus 1, 2. Hence its determinant will be 0. In this form also we can discuss. Next, it is an upper triangular matrix. Always the determinant is nothing but product of the diagonal elements. So 4 into 1 into 2 into 2, that is 16. Determinant of U is 16. Now what is the lower triangular matrix U transpose? What is determinant? We know A and A transpose have same determinant. So in this case also determinant of U transpose is 16. What is inverse? 1 upon determinant of U inverse is 1 upon 16. Next, Cramer's rule. As usual, first of all, what is A? A is nothing but 2, 5, 1, 4. What about the corresponding determinant? D is how much? 8 minus 5. 8 minus 5, how much? 3. Next is A1. First column will be replaced by 1, 2. 1, 2, 5, 4. What is D1? D1 is 1, 4 minus 10. So minus 6. What about A2? A2 is 2, 1, 1, 2. 4 minus 1, 3. So this implies D3, D2 is equal to 3. So what about the solutions? X1 is equal to D1 by D, that is minus 6 by 3, that is 2. X2 is equal to D2. D2 by D, that is equal to how much? 3 by 3, that is 1. So what about the solution? X1 is equal to 2 and X2 is equal to 1. This is the solution. Now a box this has edges like this. Find the volume and also find the area of the parallelogram of each face. Now suppose this point is A, this point is B, this point is C, this point is origin O. So volume of the parallelepiped is equal to the determinant 3, 1, 1, 1, 3, 1, 1, 1, 3. This determinant cube units. That is equal to how much? 3 times 8 minus 1 times 3 minus 1. Okay, the 3 minus 1, 2 plus 1 times 1 minus 3 minus 2. So how much it is? Minus 4. 24 minus 4. So it is 20 cube units. Okay. Now the second part. That is, find the area of each parallelogram face. So there are 6 faces. One is having A and B as its side, another B and C as its side, another C and A as its side, likewise 2 each. So there are two sides having the same value. So first let us consider the parallelogram having A and B as its sides. So represented by the parallelogram having 0 AB. Then represented by 0 AB. What it will be? Observe here, this side. Here both third component is fixed. That means it is in the xy 1 unit above the xy plane. So the determinant is 3113 because third side has no significance. So how much it is? It is 8 square units. 8 square units. Likewise, one can find out the value for BC, for CA, each one will be 8 square units. So with this, today we will conclude our video. In next video, we will discuss about the concepts of eigenvalues and eigenvectors. Thank you for your patience listening.